And now let's move on to Eiley, who will talk about mesopelagic fish as well. Nice. So that'll be a fish-focused JETZON call, which is great. Mesopelagic fishes are important prey for a diversity of predators. Take it away.
Thanks so much, Svenja. I'm really grateful for the chance to share some results with you guys today. Can you see my screen okay?
Yes, I can.
Okay. Awesome. So this project should come, and our results should come as no surprise to anyone here who studies the mesopelagic zone and is well aware of the importance of mesopelagic organisms. But I found in some of my early research, it was difficult to make the case for why the mesopelagic zone is so important and why I was so interested in pursuing it. So work that the JETZON Early Career Group, which Svenja and I were a part of, as well as others on the call, we recently came out with a paper that talks about how mesopelagic organisms are subject to potential anthropogenic effects occurring at the surface, and they're not this separate entity disconnected from the surface, but in fact pretty interconnected. And in most papers that focus on the mesopelagic zone, the two kind of items that always come up as justification for the mesopelagic zone is they're important for carbon export, of which they very much are, and also that they're important as prey for many higher trophic level predators. If we think about, a day in the life of a mesopelagic fish, in this case, this is just a northern lampfish heading up to the surface to feed and retreating during the daytime at depth to evade predation. There's quite a few mouths out there that are looking to consume them. I couldn't think of a better term than skydiving predators to describe the foraging behavior of seabirds, of which are a major global predator of mesopelagic fishes. They're experiencing predation from epipelagic predators who happen to be in the surface at night when mesopelagic fish, some of them at least, make it all the way to surface waters. There's deep diving predators whose range extends into the mesopelagic zone and are sometimes targeting mesopelagic fishes. There's mesopelagic predators themselves who also inhabit mesopelagic depths and feed on mesopelagic fishes. And finally, there's deep diving predators who are air breathing, such as marine mammals that can make it to depth. So there's quite a few mouths that they have to feed. And I think work by Robeson had mentioned that these vertical migrators are running the gauntlet of predators, and that's very much true. However, these were just pictures that I happened to find readily available. These were not cherry-picked to describe specific predators, but for each of these predators, and in many cases, most of the predators that we're aware of, there is records that mesopelagic fish are important prey. For example, for the kittiwake pictured up here, they know that during periods of decreased nearshore neritic prey, myctophids, especially, and mesopelagic fish generally tend to be an important constituent of their diet. There's a record of salmon eating duck-billed barracuda, northern elephant seals. It's been demonstrated that mesopelagic fishes are considered critical prey for that deep diving species. In the realm of mesopelagic predators, it's viperfish, if I remember, preys heavily on migrant species such as myctophids. And so we know individually that predators in some cases rely on or occasionally consume mesopelagic prey. But to date, there hasn't been a more ecosystem level assessment of the role of mesopelagic fish as prey to a broader range of predators. And so this study used a great data set of predators that were not cherry-picked for mesopelagic predators, but just represent independent studies that occurred in the California Current region. And were compiled by a few of my colleagues at NOAA at the Southwest Fisheries Science Center, especially Joe, who went around knocking on doors and asking people who had done diet studies if they would be willing to share their data, and compiled this great data set that includes 143 predator taxa and over 100,000 diet samples. And it's the raw diet data. So regardless of trophic level and position, these data were just compiled based on what was available. And I thought this would be a really good demonstration of the role of mesopelagic fish because, as mentioned, it was not specifically designed with mesopelagic fish in mind. And in fact, most of the bias within these data are for more nearshore fishery species, since a lot of this data comes from NOAA as well as universities. Also, just a little plug for this data, if you're interested, it's publicly available. It's hosted on NOAA ERDAP site, so feel free to play around with that too. The first step in this project was we printed out a list of all of the fish prey that was listed in the California Current Trophic Database and had to define which ones were mesopelagic. And this just involves spending a lot of time reading through a bunch of primary literature, as well as looking through fish base. And we identified any fish that had an adult distribution at mesopelagic depths during the daytime as mesopelagic. In some cases where identification only occurred to the family or genus level, we ensured that all members of that particular taxonomic group were mesopelagic, or at least the ones within the California Current. I do have to say that although we're interested in mesopelagic fish, and I'll use that term throughout, many of these species also included distributions down to bathypelagic depths. So I say mesopelagic, and all of these species had ranges that corresponded to mesopelagic, but in some cases also extended much deeper. So of the 323 total fish taxa identified as prey in that data set, 62 were mesopelagic. And in terms of who was eating these mesopelagic prey, I think one of the biggest things that came out of this for me was just, it was a huge diversity of things. These are all of the predator taxa. It was about 25% of the taxa within the database had consumed at least one mesopelagic taxa as prey, and it crossed a lot of different taxonomic groups, including, elasmobranchs, rockfish, dolphins, sharks and rays, and pelagic squids, and included quite a few species of either federally managed status or protected status. And here the orange represents protected species and the blue is species that are federally managed. And so, again, further justification for why mesopelagic fishes should perhaps be better considered when we think about important prey. Also impressive was the number of mesopelagic just items within this data set. There were 16 families of mesopelagic fish represented as prey in the guts of these predator species. I think often, especially in ecosystem modeling, we identify myctophids or one group of mesopelagic fish, but I think a surprising result for us was that there were quite a few other taxa that were represented. Diet studies can be a challenge, especially when they've been identified through different methodologies. And so one of the metrics that we used to quantify how important, quote unquote, a mesopelagic fish may be for a predator was to look at a measure called the frequency of occurrence. And you can just think of this as the proportion of diet samples that contained mesopelagic fish for all non-empty stomachs for a given predator species. And when we look at this, in blue, we have the frequency of occurrence of mesopelagic fish out of all diet samples for a given predator species, listed in white on the left. In orange is just the total number of diet samples available in the data set. And you can see that for quite a few species, including the top 11 in particular, mesopelagic fish were a pretty substantial item of prey for these predators. Those top 11 species had over 25% of all samples within the database contained mesopelagic prey, which is just an indication that mesopelagic prey, feature prominently in their randomly collected diets, and thus are likely an important prey item. Also included on this plot is the frequency of occurrence of coastal pelagic fish species. This includes anchovy and sardine, as well as I think there were 5 species in total identified by the Pacific Fishery Management Council. And that was important for us to include because coastal pelagic fish species are considered essential prey within the California Current system. And because of this designation have received quite a bit of research attention. And so by demonstrating in this plot that there were 21 species of predator taxa, or 21 predator taxa, not necessarily species, that had a greater frequency of occurrence of mesopelagic fish compared to coastal pelagic fish, that again, perhaps there's justification for considerations of what constitutes important prey. Those top 11 species that had mesopelagic fish occurring in greater than 25% of all diet samples examined in the data set included representation from across multiple trophic and taxonomic categories. I think the highest was a little bit of a surprise, with 89% of all diet samples from the northern right whale dolphin occurring as the highest. But also there were in total 4 dolphin species, 4 pelagic squid, taxa, kind of shelf slope associated rockfish, the common thresher shark, as well as swordfish, which is of course an important commercial species within the California current. And what jumped out to me in looking at these was just that they covered a whole range. This data set didn't include seabirds and a lot of mesopelagic predators, but of these predators that were included, they really did cover quite a large breadth of habitat and trophic position. So beyond knowing that mesopelagic fish are important prey for higher trophic level predators, we wanted to look at who specifically is eating who and whether or not any family of mesopelagic fish may be featured prominently within this study. And we found that myctophids, perhaps not surprising because there is a lot of information of independent records of myctophids being important prey, but they ended up being consumed most frequently. They occurred in over 2,000 stomachs, or scat samples, I suppose, 2,600 diet samples. And they also were consumed by the greatest diversity of predator taxa. So they really jump out when you look at this plot. But also there are other taxa, this was identified just by mesopelagic family, that were consumed uniquely by predator taxa. So there may be some selectivity going on amongst predator species that are targeting mesopelagic fishes, and some only ate one family of mesopelagic fish, whereas others seem to consume a wide diversity of mesopelagic fish prey. If we examine the length of the mesopelagic prey that was captured for some, not all records, but for many records, there was a prey length associated, and compare that to coastal pelagic species of fish, you can see that in general, the mesopelagic prey tended to be smaller. There was a peak about 5 centimeters compared to about maybe 12.5 for coastal pelagic species. So in terms of ecological role that these organisms are playing in the food web, it's possible that mesopelagic fish are available to a wider variety of predators with different physiological requirements such as gape. One thing that was recorded in the California Current Trophic Database that was really helpful for this study was the position of the collections, predator collections. Unfortunately, each individual predator did not have an associated position and depth, so we don't know which, where they were foraging, which depth in the water column, but we can kind of infer a little bit about habitat by looking at the bottom depth underneath wherever these collection depths occurred. And the map on the left depicts the proportion of predators caught at a given collection site that had consumed mesopelagic prey. And if you just glance at it generally, you can see that there's an increasing importance and prevalence of mesopelagic prey in the diets of predators with increasing distance from shore. Again, this data set was not intended to target mesopelagic predators, and as such, most of the collections occurred pretty near shore. So you can see that kind of lighter tone kind of lines the coastline, but as you move further out, the proportion of predators that had consumed mesopelagic fish increases. If we break this down into different habitat types, we have on the plot on the right, the bar plot on the bottom, we have scat, I think fur seals and California sea lions at rookeries in Southern California. So that's actually onshore. Their depth is positive, I guess. And the shelf we define as bottom depths between 0 and 200 meters, the slope 200 to 1,000, and deep habitat we define as those collection locations that were collected over bottom depths greater than 1,000 meters. So if we look at that, it follows a pretty predictable pattern in that most mesopelagic fish were collected over the slope and deeper habitats, with about 40% of collections that had mesopelagic fish occurring over deep depths compared to about 29% over the slope. As expected, there was a much smaller proportion of collections of predators that had consumed mesopelagic fish over the shelf, although there were some. And somewhat interesting is that those colonies of marine mammals that were occurring onshore, about 36% of those contain predators that had consumed mesopelagic fish. So this shows that mesopelagic fish are important as prey, not only in offshore waters, which we would expect, but also over the slope, sometimes on the shelf, and are potentially conveying offshore energy onshore through those marine mammals that live onshore. Another way that we were interested in looking at this is breaking down the collection location by species and seeing where an individual predator that had consumed mesopelagic fish encountered that fish, over which bottom depths. So once again, on the X, we have onshore as a habitat type, the shelf, slope, and deep. Again, these correspond to bottom depths, not actual capture depths. But you can see that for many species, most predators that had consumed mesopelagic fish were captured either over the slope or over deeper habitats. However, again, there are some species that the greatest number of diet samples that had predators which had consumed mesopelagic fish occurred on the shelf. And we think this may be either from horizontal migration of mesopelagic fish into these shallower waters, or by nocturnal migration by the predators over deeper depths and a return to the shelf, or potentially the congregation of some of these species over topographic features, which may help convey mesopelagic fish onto the shelf where they get trapped. So the major takeaways from this study, the first was that mesopelagic fish, of course, were eaten by a diversity of predators, including many economically valuable and protected species. I put these two little figures in here to remind myself that this data set didn't include any seabirds, as I mentioned, and we didn't include any mesopelagic invertebrates. Mesopelagic invertebrates are also providing a substantial amount of prey for many predator species and should certainly be included in future work. So our study certainly underestimates the role of mesopelagic organisms generally as prey to the broader ecosystem. So some important predator taxa, as mentioned, occurred in over 25% of all diet samples. But in general, the takeaway here is that we need to better include mesopelagic fishes in ecosystem models and food web models, especially within the California current. There have been some major attempts to include, a functional group for the mesopelagic, but it often only includes myctophids. I think there was one that included myctophids and dragonfishes, but in general, our results which found 16 families of mesopelagic fish represented, which are going to respond most likely distinctly to different oceanographic forcings, and potentially be preferred by different predators. That complexity is not currently being taken into account. In one study, I think it was by Dufault in 2009, they estimated the effects of a reduced population of mesopelagic fish on albacore. And depending on which parameter they used, which had looked at diet of albacore and the proportion of mesopelagic fish, a complete decline in mesopelagic fish either had no effect on albacore or reduce the population by 20%. And so these values are really important in input into ecosystem models, and yet very often mesopelagic fish, and especially the diversity of mesopelagic fish, are not being taken into account. There's evidence in the literature that as oceanographic conditions change, mesopelagic fishes may play a more increasingly prominent role as prey to higher trophic level predators. This has been shown in seabirds. Once again, with the kittiwake is an example of that. When there's declining neritic prey, myctophids feature more prominently in the diet. And in the California current, there's quite a bit of research that has shown that in warm years, either based on marine heat waves or El Nino, or just generally relaxed upwelling, there tends to be an incursion of oceanic species closer to shore. And that tends to coincide with decreases in more coastal pelagic prey. And so it's possible that mesopelagic fish are offering a buffer during times of warming in the system, and thus should certainly be taken into account so that we can better understand how the ecosystem as a whole will adapt to climate change. And finally, the Pacific Fishery Management Council has kind of used the precautionary approach in a great way to ban the future fishing of 5 mesopelagic fish families, including myctophids, bathalagids, paralipidids, and gonostomatidae, as well as pelagic squids. And I think our research justifies that decision because they were found in each of the management units that they were trying to protect. I think it was highly migratory species, salmon, and I think it was groundfish maybe. And our research indicates that this action has preserved quite a bit of biomass that is likely important for these economically and protected species within the system. So I think with that, that was everything I had. I would love to take questions. If you're interested in the paper, I listed the DOI there, and I had most of my code made available through the GitHub site there as well. Thanks also to my collaborators at UC Santa Cruz, Jerome, and at NOAA, John Field and Jared Santora.
Excellent. Thank you. That was amazing. What an amazing data set. Like, this is great. What a gold mine, really.
Certainly.
Yeah.
I should have that included as well as a thank you to everyone who submitted data to that.
Because... I mean, fair enough, but yeah, it's good. I mean, you know, it's not only collecting the data, but also it's making it accessible for people like you, but also everybody else to use it. It's pretty amazing. Love it. George, you have a question.
I did. So I was interested, but not really surprised to see the benthic predators, like the Bathyrahas, right? The skates and the rays, which I know eat mesopelagic fish. But it's an interesting take when you think about, just by definition, mesopelagic fish should be up in the water column. And therefore, what are they doing being eaten by fish, by things that are on the bottom? And we've seen them being eaten by rays and crabs and sea anemones, but it always seems more accidental, right? The fish run into the bottom and somebody grabs it, all right, because it's stunned for a few seconds. And I don't know if it's because we're shining bright lights at them and we're stunning them with the bright lights of the remote vehicle, or if that's just sometimes what happens when they're migrating down and they descend over the shelf instead of the canyon. You know, they bump into it and something eats them. But I guess I was just surprised to see them contributing as much to the predation of mesopelagic fish. And I was just kind of curious what you thought about that.
Well, it's so nice to hear from you and having actually had eyes down below, because this is the kind of thing I think about, but I haven't been able to witness, so it's totally conjecture on my part. But I do think there's been some record. There was I think yellowtail rockfish tended to congregate around the mouth of canyons, so that presumably when these mesopelagic fish are, undergoing their diel vertical migration, if they get swept over just a little bit, or maybe they get confused and disoriented on their way back down, that they're kind of there to anticipate them. So it's hard to say. Again, I think a lot of it is probably accidental. If there's a fish in front of most of these predators' mouths, I'm sure they'd go for it. But in some cases, it seems to me, or at least I would assume, that some of these organisms are trying to specifically target areas where they might have access to mesopelagic fish. But it is really perplexing having those benthic critters on there. And I think one thing, wonderful work by Kelly Benoit-Bird at Mbari had shown that there was actually horizontal migration occurring, at least in the mesopelagic boundary layer in Hawaii. And I've been so curious whether or not a similar thing is happening here, because we assume it's just this vertical migration, but it's possible that they're traveling, kilometers onshore as well. And maybe they just don't make it out in time before the skates wake up and decide they're hungry, or, maybe on their way back out, they're encountered and end up breakfast. But I don't know, but I'd love to pick your brain on what you've seen with the ROV, because it's all conjecture from my end.
Very cool. Thank you.
Awesome. Yeah. Sony Gitu. Sorry, how do you pronounce your name? You raised your hand too.
Yeah, thank you. You got it right, Sony Gitu.
Awesome. Thanks.
Yeah, just being a little curious and following with what Josh said, could you maybe give a little explanation on the food web design of mesopelagic fish, and how they also contribute to climate change mitigation?
Oh, that's a great question. I think as far as the food web goes, I know there's been a lot of great work that has been trying to disentangle the mesopelagic food web itself, if that's what you mean, and trying to look at, who within the mesopelagic zone is consuming who and what. As far as most of the predators within this system, most of them are epipelagic predators, and a big thing that's missing from this data set is the existence of mesopelagic predators. So I think there's still some gaps in our understanding of the food web, but what seems to be emerging is that there's an entire system in the mesopelagic zone reliant on both mesopelagic, daytime mesopelagic critters, as well as those epipelagic, epipelagic migrants, or heading up to the epipelagic zone to consume some of those more surface associated prey items. So I don't know if I can answer, the full food web. I know that future work would definitely benefit from including mesopelagic predators when we consider all of our estimates of export and just those interactions amongst species. But, and then I'm sorry, what was your second question?
How do they help in mitigation of climate change?
Oh, yes. Well, what the thought is that during periods of warming, and this has been shown in the Southern Ocean, I guess would be a good example to start with. Work by Saunders had shown that mesopelagic fish, myctophis in particular, are kind of central in the food web. And they found that in times when krill, which is also a very important forage organism, tended to decline because of warming temperatures, there were smaller mesopelagic organisms that filled that niche for hungry predators, and they kind of acted as a buffer. So when other more typical forage species declined, mesopelagic species tended to be more available and thus kind of buffered the system. Current system, there's also a lot of evidence to suggest that in warm years, when upwelling tends to be lower, again, that could be due to a variety of reasons, but there's work done to show that El Nino and heat wave events have changed a lot of the temperatures near shore, that during those times there tends to be a greater abundance of mesopelagic species and a coincident decrease in coastal pelagic species. So my thought there is that if coastal pelagic species tend to decline during that window of time, that mesopelagic fish may offer a buffer, again, provide some resilience in the system so that there's still prey available for some of these higher trophic level predators. And part of my other work is looking at using acoustics data to examine the effects of the heat wave on mesopelagic fish. And just anecdotally, I've been able to show that during 2015 and 2016, when along the US West Coast, we had what was called the blob, and it was really warm conditions, the biomass in the mesopelagic was significantly greater. So the thought being maybe they're offering kind of a backup food item during those strange times.
That's interesting. And also, I mean, if you think about it, that the community composition might change as well because of temperature. So yeah, it would be another thing, just not only biomass, but also what's actually there. Interesting to look
Certainly.
at. Mm.
And mesopelagic fish are also really responsive to, the community changes quite a bit with oceanographic drivers. And they've shown that in Southern California, there's been, like, with an incursion of more equatorial water, there's been more warm water associated mesopelagic fish that have really come in and become more abundant. So yeah.
Excellent. Yeah. There's a question Ying asked a question. Is very informative talk. Thanks for that. I'm wondering the climate change impact. On the mesopelagic fishes, e.g., adaptation zone or abundance variation. I think we kind of covered it a bit.
Sorry, I just missed that.
Sorry, yeah, reading is hard. Ying is wondering the climate change impact on mesopelagic fishes, for example, if there's an adaptation or if there's a variation in abundance.
Totally. Yeah. Like I mentioned, there's not a lot of long-term data on mesopelagic fishes available, although there are some exceptions to that with Cal Coffee and the NOAA survey that I participate in. But so far, it seems like the composition, just like we were talking about, has changed with more warm water associated species becoming more abundant. And also the biomass tends to be higher during warmer years, with the thought that oceanic waters are kind of sloshing closer to shore, not necessarily that the overall abundance has changed.
My question was, because you have all the data where the predators have been collected, or the contents, the stomach contents have been collected. But I mean, what about all the migrating species who migrate maybe further offshore and then being collected inshore, but maybe during that time offshore they're just feeding even more on mesopelagics or other species. So obviously they can't account for everything, but this would be an interesting thing because you probably just account for where they've been collected, but in the end they're moving around. They don't know that they're supposed to be there, you know.
Absolutely, that's a great point, and I hope that future work could kind of focus on like what times mesopelagic fish tend to be more important, or you know, yeah, as you mentioned, they're migrating everywhere. A lot of these species can move quite a bit, so it'd be interesting to better understand what some of those dynamics are. Certainly, this is just like one snapshot.
Yeah, totally. Just before I forget, there's the JETZON YouTube channel. I just copied the link into the chat. I think most of you are aware of it, but so if you want to catch up with other talks previously and from previous calls, they're usually uploaded within the next week or something afterwards. So, you know, if you're keen to, if you just missed part of the talk or something, then just have a look there. Yeah, and then maybe the blob is back. Ooh, we'll see.
Oh,
That's
things are looking like they're heading that direction. It's a little scary.
No, yeah. Same in New Zealand, we have a really mild winter now. And we're like, oh no, what about the summer? Australia the same. Like there will be another bushfire season upon us. So yeah, we'll see.
Scary times.
Yeah, definitely.
I should mention too, there's, you know, the effects of that on the mesopelagic zone proper too is a whole different story, whether or not that habitat is being constricted, and there's so many things to be afraid of.
Well, you know, there's a lot of research, I guess, as well. You know, see it this way, that you know, there's definitely a lot of changing. So we will hopefully have a job at, you know, researching it. It's how I kind of keep positive somehow.
It's a good perspective to take.
Yeah, well. Anybody else having a question? Otherwise, Alvina, yes, of course.
Hey, thanks, Venya. Thank you so much, Ely. That was a great talk. And I'm so interested in your research results and hopefully in you know, kind of building off of that in the future. I was kind of along those lines. I'm starting to think about which metrics to use as measurements of importance of mesopelagics in diet. And I was curious, and I can certainly check out in your paper too, but when you looked at frequency of occurrence, and say for some predators, 75% of diets contained mesopelagics, did gut content qualify as containing mesopelagics if it had, say, just one individual, or did it need to be 5% of the mass of the stomach content, or the you know, the counts, or yeah, I'm just curious about that kind of that bar, and then also how you decided to choose that as opposed to, like, for example, percent of stomach content that is mesopelagic for individuals.
Totally. Yeah, for us, the bar was just one. So we didn't even look at how many total mesopelagic fish were present in the guts. It was just if mesopelagic fish was present. And it was a really basic measure. And part of the reason we did that because within the database, as I'm sure you will explore or have already, there's just a wide range of methods that were employed for each of these individual studies. And it was really difficult to use some of the other metrics that take into account weight, you know, so the biomass of prey, as well as the length. It just wasn't totally consistent across all these different surveys. And some of these were looking at scat, while others were marine mammals that had been incidentally caught. And there was just such a variety of methods that we just chose kind of the most bare minimum metric to look at and consider important. But certainly within the database, there's awesome records for an individual predator taxa through time as well that is consistent and has, you know, consistent methods throughout. So you certainly could look at other metrics. We just chose the more basic just to kind of get that broad swath of, are they there or not? But yeah, there's definitely other metrics you could do.
Okay, thanks. That's super helpful. Yeah, I mean, you're covering so many different species and studies that it makes sense that, you know, presence absence is maybe the best way to go.
Right.
And I'm sure your work will help guide, you know, which predator species to choose if you did want to look more at like percentage of gut content where that's available. So
totally. And I hope that you pick up the baton, because I know you have some wonderful ideas. So look forward to seeing what you come up with that.
Thanks so much. Awesome talk.
Beautiful. Any last questions? We have 3 minutes left. Otherwise, I'm happy to close this call. Thank you so much, everybody who presented. Wang and Ailey was great. All the other things as usual. That's fine. Happy to organize things. It's basically selfish, as I said. You know, I listen to all these amazing studies, meet new people. It's great. It's just for me, basically. Yeah, if you wanna catch up on, as I said, other talks, they're uploaded usually. Depends on when Adrian has time to do that, but you know, hopefully soonish. And then yeah, otherwise see you probably in 2 months when I organize the next call. Next month we have this big Twilight Zone symposium at Woods Hole, and then I fly over, you know, to US also, and seeing George hopefully. So then so we will skip next month, but then the months after we will have another call and hopefully more mesopelagic research. It's really exciting. Awesome. Thank you so much. I will stop the